Hey guys, it's Mr. Grun, and this is 8.3, Adding and Subtracting Rational Expressions. In this video, we're going to be finding a least common multiple. Now, the reason for this is what we're trying to work toward is finding a least common denominator so that we can add or subtract rational expressions. If you're adding or subtracting fractions, you need a least common denominator. So that's what this is really about, is just focusing on the skills that it takes to come up with a least common denominator. Okay, so if we are looking for just numbers, right, no x's, no y's, anything like that, all we're doing is we're looking for the lowest common multiple. So what that means is if I was counting by 4s and I was counting by 6s, where's the first place that they would match? And you can literally just do this by counting out the numbers, right? If we start with a 4, the next would be 8, then 12, then 16. If I can do the same thing with 6, 6 would then be 6, and then 12, 18, 24. I'm just counting by 6s. The first place that they match is the 12, right? Here and here. And so the least common multiple between 4 and 6 is 12. Between 6 and 8, I can do the same thing. 6, 12, 18, 24, just counting by 6s, 8, 16, 24, 32. Usually if you count, 3 or 4 multiples is all it's going to take probably to find the least common multiple. But if it took more, then you just keep going until you found ones that would match. So between 6 and 8 is 24. And then between 4 and 12, if I count by 4s, 8, 12, 16, well, right away, right? 12 already matches. 12 is a multiple of 4, so that means 12 is the least common multiple. I didn't even have to count by the 12s. Okay, when it comes to variables, x's and y's, z's, letters, right? Letters to exponents, the least common multiple is always the highest exponent. So just to make a quick extra example here, let's say I was talking about x cubed and x to the 5th. Well, when we're counting these, we're not counting them like x cubed, 2x cubed, 3x cubed like that. We're actually just adding powers of x. So the counting here, like this is my starting point for each of them. This side would be x to the 4th, x to the 5th, x to the 6th, like that. This side would be x to the 6th, x to the 7th, x to the 8th. And so the first place that they match is always going to be the, whichever one is the highest exponent of the two. I can always get to x to the 5th from this lower one, x cubed, if I start multiplying more x's. Okay, so long story longer. Between these two, between x squared y cubed and xy to the 4th, our least common multiple between the x's is going to be the x squared, and between the y cubed and the y to the 4th, it's going to be the bigger one, y to the 4th. All right, so a quick example where we have them kind of mixed up. We're doing both of these. Right, so between the 8 and the 12, I'm going to count, I'm going to count by 8s and count by 12. So 8, 16, 24, 32. The 12, 24, 36, 48. Where was the first place that they matched? It was the 24. So the least common multiple, the coefficient, is 24. Then after that, between the x, y, and z, I just have to pick the bigger of the two exponents. Between x squared and x, it's x squared. Between y to the 4th and y cubed, it's y to the 4th. And between z and z squared, it is z squared. All right. That's the one I wanted. Now, that was for numbers and x's and y's where it's a product. If it's a polynomial, so something like this, right? What we're going to do is factor out the two polynomials, and then we are going to list all of the factors without repetition, without a repeat, right? Here's what I mean by that. This is, okay, multiplies to 2, adds to 3. That is going to factor to plus 2 plus 1. This one multiplies to negative 6, adds to negative 1. That is going to be a minus 3 and a plus 1. So the least common multiple between these two isn't like the product of the whole thing. I don't need to multiply an extra x plus 1 for this least common multiple. If these were the denominators of two rational expressions that I was trying to add together, the least common denominator that I would make would be the product x plus 2 times x plus 1 times x minus 3. I wouldn't count that x plus 1 a second time. This is our least common multiple. It's got all of the parts with no spares.